Hi, Peter here from Wonderstruck. This morning what we're going to do is we're going to build an electric motor. Now this electric motor is a simple design, a little bit fiddly in places, but it's not that difficult to make. We originally came across this on a website called scitoys.com many years ago, but I've seen it in lots of other places as well, so it's fairly kind of generic. Now in order to build this motor you're going to need a few things. So in terms of materials, you will need some enamel copper wire. This is 20 gauge enamel copper wire. You're going to need at least one ferrite magnet. This is, I don't know, about 4 centimetres by 2 centimetres wide by 1 centimetre thick, something like that. I've actually got 3, but you can do it with 1, that's all right. You're going to need a couple of bits of thick copper wire. Now this copper wire just came from a stripped cooker cable. I think it was a 35 amp cable, so it's nice thick copper wire. You're going to need a couple of small screws, some screw cups, or 2 screw cups. I've got a piece of wood there where I've pre-drilled a couple of little holes. You'll see what they're for in a minute. A battery holder. This one holds 4 AA's, but it doesn't need to be that big. You can use 2 AA's if you want to. Obviously the bigger the voltage you use, the better your motor is going to work. You're going to need a clip to go on the top of the battery holder. So this just comes with 2 wires with soldered ends on. I've got 4 batteries because my battery holder holds 4 batteries. And in terms of tools, a little pair of pliers would be useful, a craft knife, a pair of scissors, and a bit of emery cloth there. Oh, and don't forget, most important thing, a nice cup of tea. Biscuit is optional. I'm on a diet, so I haven't got one. Right, so what do we do first of all? The first thing you need to do, you can do this in different order if you want to, but what I'm going to do first is I'm going to get my copper wire, and we need to make sure that this is nice and clean. When you get it out of its insulation, it may well be a little bit grubby, so just give it a bit of rub with the emery cloth, like this. You can always do this again a bit later if you find it needs it. There we go, that'll do. And the first thing you want to do is get your pliers, and you want to bend a little kind of loop in the end of the wire. So you want to do it like this because you want the base of the loop to be nice and smooth. You don't want the wire to kind of end here because this is going to hold the axle of your motor. So it needs to be like that. Do the other one as well. Made that a little bit small. Should be alright. And then make sure that the stem of the wire is nice and straight. You want to bend the bottom out a rectangle, a right angle, like that. You want to do them about the same on each one. So these are things that are going to support your motor. Oh, I've done that the wrong way, haven't I? If you do it the wrong way, it's easy to correct, just twist it. Like that. Okay. Now, next thing you want to do is wind your coil. Now to do that you need about 1 metre of enamel copper wire. Oops. It has to be enamelled wire. The enamel refers to a coating that's over the copper which forms an insulating layer. Now the enamel is very thin and flexible, so it makes it ideal for turning coils and things like that. Obviously if you use normal wire with big thick plastic insulation on it, it takes up a lot of space, so you get less coils per unit volume. Now what I tend to use is one of the batteries to actually form the coil on. So start off with a bit of the wire sticking out, and then just neatly, as neatly as you can, wind the wire around the battery. The battery is good to do this round because it's nice and smooth. It makes it easy to actually slide the coil off when you're finished. In fact, I've probably got a little bit too much wire here. Yeah, a bit too much. That's my coil. I said do it neatly. Mine doesn't look particularly neat, but it will do the job. And so what I'm going to do is I'm going to cut just the end of that bit off there. And then you carefully slide the coil off the battery. Now at this point it will try to kind of ping apart a bit. You want to try and keep it together. And then what you do with the two ends, you fold them, bend them through the centre of the coil, pull them tight. Do that a couple of times. I'm doing it 3 times because I've got nice long pieces of wire there. Like that. And that obviously is going to hold your coil together, and it's also going to form the axle or the shaft of your motor. Like that, nice and tight. Now, what we want to do is try and straighten those out. Now, this is the tricky bit because this coil is going to be mounted inside these copper wires. So for it to spin, because the forces that are going to turn this coil are not that big, so it needs to be as well balanced as possible. So you can see my 2 bits of wire don't actually kind of line up very well there, so I'm going to try and pull that down a bit so they're in line with each other. You then want to look at it from above and bend the wire around, and again use your pliers. Like so, so that the wires are nicely in line that way and that way. Now we can fine tune this in a little bit. Right, so now we're going to turn our attention to the base of the motor, the screws and the screw cups. Well, that's one little thing that you're going to need, which I forgot, obviously, is a screwdriver. So we'll have a short commercial break in a minute while I go back out to the workshop and find a screwdriver. So what we're going to do is we're going to get the motor shaft, the motor supports, and we're going to trap them between the screw cup and the board by tightening that screw up in there, by screwing that screw down. And then the same on that side, like that. I could actually have screwed my screw holes, drilled my screw holes a little bit further, so it would have been a little bit more central. Right, so quick commercial break while I go and find a screwdriver. Let's have a cup of tea first. Right, back in a minute. Right, screwdriver. Now, what you want to do, like I say, is you want to trap that under the screw cup. So we'll just do a couple of turns on the screw. We don't want to tighten it completely up. Oh. Now the trouble is, if the screw cup falls back down on the wood, it's hard to pick it up with your fingers, so just tilt it back up like that. So don't tighten it completely, because the other thing you want to do is you want to connect these wires. So these you also want to trap under there, and the best thing to do is slide them actually underneath. I don't know if you can see that, but I've slid the wire, it's difficult to show you, slid the wire underneath the base of the thick copper wire there, so when I tighten the screw cup it's going to tighten that down onto it, so hopefully we should get a decent electrical connection. There we go, and that holds that nice and upright. And then we do exactly the same on the other side. piece of wire underneath. A little bit fiddly. It's handy if you've got somebody else to help you, they can hold the wire while you tighten the screw up, or vice versa. Right, so there we go. We should now have a pretty good electrical connection. Now the next thing we want to do is make sure that these are nicely in line, and we want to trim our wire on our coil so it's going to fit nicely in there like that. Right, so if I cut a little bit off both sides. You can obviously use wire cutters if you've got some. Right, there we go. Now that's not too badly balanced. It does tend to kind of favour one side, but it might be okay. So we'll leave it like that at the moment. Right, now your magnet is going to go under here. Now my motor stands are a little bit high. If you find that your magnet is a long way from your coil, you want to stand it on a matchbox or something like that. So it wants to be as close to the coil as it possibly can be. So I'm actually going to use 3 magnets just to bring them a little bit further up, like that. Now, this is the really important bit. At the moment, if I put my batteries in, my battery holder, and connect it up, nothing's going to happen because an electric current can't flow through it because the copper wire of the coil is coated with the enamel, the insulator. So to allow current to flow around this, I've got to scrape some of that off. Now, when an electrical current flows through this coil, it's going to create a magnetic field. It's going to produce a magnetic field. That magnetic field is going to interact with the field from the permanent magnets and is going to cause the coil to turn. Now, the thing is, the direction of the magnetic field, and hence the direction the coil turns in, depends on the direction the electric current flows through the coil. Now, if our electrical current is flowing the same way each time as the coil turns, because then the magnetic field has turned with the coil, it's going to interact in the opposite way with the field from these magnets. So it's going to flip it back again. So our coil is really just going to sit there doing that. Now, that's where it comes to scraping the enamel off here. What we want to do is we want to scrape only half the enamel off, or off one side of the axle there, so that the electrical current will flow through here, spin the motor in this direction, but then it will turn the axle so that the side of the axle that's still coated with the enamel will then come into contact with these conductors and the current will stop. So the momentum of the coil will carry it on round until the bare side of the axle comes into contact with this again and gives it another little kick from the current flowing through here, producing the magnetic field. So this should then spin continually. Right, so that's what we're going to do. Now you can do this with sandpaper or emery cloth, but I find it's a lot easier if you use a nice sharp craft knife. Now the important thing is you scrape off the enamel on the same side, on both sides if you like, of the axle. It's easier if you put the coil on a piece of wood or something like that, and then just scrape along there. Now, taking care to keep the coil the same way round, you do it on that side as well. Now, these things very rarely work first time, but we'll see what happens. If it's all, you know, if you've done it all correctly and you've cleaned these copper wires nicely, you should, as soon as you make contact, you should feel some kind of force acting on the coil. And there we go, we have one very simple electric motor. Not particularly well balanced, but hey, could say that about anyone. So I'll just keep my finger there, see it spinning nicely.